Hi, my name is Renata Pedrosa, and in this video I will explain how I experimentally determined the spring constant of a spring and how I used it in my analytical model. For this experiment, I used a spring, a digital scale, bags of rice and pasta, and plastic bags to hold the masses. Since I did not have standard weights, I created my own by filling bags and measuring their mass using a digital scale. Later on, you'll be able to see that here's the spring without any load applied, which shows its original length and how the system behaves before adding any force. For the first trial, I used a mass of 150 grams and measured how much the spring stretched when the load was applied. For the second one, I used a mass of 383 grams and again measured it. For the calculation of the K constant, first I recorded the original length of the spring, which was 3.5 centimeters, and used this as my reference point. For the first experiment, I applied a mass of 150 grams or 0.150 kilograms, and the spring extended 3.8 centimeters, so the displacement was 0.3 centimeters or 0.003 meters. For the second experiment, I used a mass of 383 grams or 0.303 kilograms, and the spring stretched to 4.3 centimeters, giving a displacement of 0.008 meters. I then converted the mass into force using F equals mass times gravity, which gave me a force for the first one of 1.47 newtons. And for the second experiment, using the same formula, it gave me a total force of 3.76 newtons. Next, I applied Hooke's law and solved for the spring constant by dividing force by displacement. For the first trial, K was 490 newtons per meter, and for the second trial, it was 470 newtons per meter. I then averaged these values to get a final spring constant of approximately 480 newtons per meter. And finally, I used this value in my analytical model. Using this equation for elastic potential energy, 1/2 times kx squared, I calculated the stored energy to be about 0.01536 joules. This shows how much energy the spring can store. This energy value allowed me to predict how the system would behave since the stored energy in the spring can be converted into motion. This shows how the experimentally determined spring constant can be used to analyze and predict the performance of the system. Thank you.